Okay, one last time, I think. Earth's surface is heated unevenly. Causes all kinds of problems with the atmosphere. Some surfaces are hotter, some surfaces are cooler, which means that the air above certain places is going to be gaining more thermal energy from the surface if that part of the surface has more thermal energy to get rid of. Because remember, matter doesn't like to be hot. If it has a chance to give it to matter that has less, it will, through the process of conduction. Hotter surfaces conduct more thermal energy to the air that's close to the surface. Okay? And what we get is we get different types of air pressure. Okay? We get some places in planet Earth where we have more thermal energy being conducted to the air from the surface, creating low pressure air. Okay? So this is higher thermal energy, and it has lower density because there's less mass per volume. Okay? There's less particles in this box. And having less density relatively causes this kind of air to want to float and rise up. Oppositely, we have our high pressure air, which happens because some parts of the Earth's surface don't have as much thermal energy to conduct to the air. So this air would be colder. And being colder, it has less thermal energy. The air particles are packed closer together, increasing its density, and higher density air will likely want to sit low and close to the ground. Getting closer to the ground means that you're more likely to gain thermal energy from the ground because the ground doesn't want the thermal energy that it has from the sun. So basically what starts to happen is we get these convection currents, right? Where the cold air sinks down, gets to the surface, right? And the surface heats it through conduction. So essentially that turns into warm air, okay? And that warm air, because it's less dense, will rise. And when it gets up high, because the air that was there is colder already because it's further from the surface, the extra thermal energy that we see here gets transferred and it loses its thermal energy, becomes higher pressure air, which will then sink down only to get heated up and have this thing happen over. So this constant rising and falling of warm and cool air, or high pressure and low pressure air, is a convection current. But if you zoom in on a convection current, you'll notice that it always shows you these diagrams. It's always like it rises up over here, comes across and falls over here, and then it comes over. I want to show you how at the bottom of this convection current, okay, it's a cycle, it's a circle, right? At the bottom, where the surface is, you're actually going to be able to experience what it feels like for the air to move. And there's a technical term. It's a very complicated word. I have a difficult time spelling it. And that word basically it's a term that means air particles moving. And it's called wind. Okay? We don't see air particles move when the wind blows, but we could feel it. When you feel wind, you're literally getting pegged in the face with a bunch of air particles that are going from crowded areas to less crowded areas. And I'm going to be able to show you this using a simulation called a convection box. Okay, what I have here, all right, is it's a chamber, and inside this chamber I have a candle, which I will light. Okay. Once I can get a match. I should just use my blowtorch. Where's my blowtorch? Uh-oh. Let me try this one. Nope. Let's try this one. Best video ever. Ah, yeah, there we go. Okay. So I'm going to light this candle. I gotta look what I'm doing. And what this candle is going to represent differential heating of Earth's surface. Notice how the candle is at the bottom of this box, right? And on the other side, there is no candle. So the candle is representing heat source, or a hotter surface, differential heating, right? And differential heating can happen in different parts of the globe, or something as simple as like being at a beach where the sand is hotter than the water, okay? So what we're gonna do is we're gonna simulate, well, not simulate, you're gonna visualize what the air particles are doing. Because we can't see air particles, right? We are going to produce something that we can see. We can see smoke. Smoke is not a gas. Smoke is tiny particles of solids. So I have this smoky paper. Okay, this is called touch paper because it actually produces a pretty decent amount of smoke. And what I'm going to do is I'm going to light the touch paper on fire until it creates a decent amount of smoke. Okay. Come on, buddy. Now, like I said, smoke is not a gas, but the particles are so small that it behaves like a gas. Okay? So what I'm going to do is I'm going to take this smoky paper, I'm going to put it in this side of the chimney. Okay? And what you should be able to see is smoke falling down. Okay, the smoke is literally being pulled down into the chamber, down this chimney where there's no heat or where there's less heat. Okay? Look at what the smoke does. It's going into there. If I put this smoky paper into the other chimney where there is a greater amount of thermal energy, the smoke is being forced up and out. So here, the smoke goes in. On the other side, the smoke comes out. Now, what you should be able to look inside here is inside the box, you should be able to see how the smoke down here is going from the cooler side over to the warmer side. And my friends, that is exactly what is happening in our atmosphere. So think of this as like a convection, right? We have our cooler air. Okay, here's the cooler, more crowded air over here. Here's the less crowded air over here. And what particles are doing is they're leaving the crowded area and going to where there's more open space for it. Okay, and once the cooler air gets over here, it's heated, spreads out, becomes less dense, and then rises. Okay, the air that's on this side is closer together, more crowded, denser, and it sinks. And then when it gets to this point, it makes its way over here, okay, because air doesn't want to be crowded. It has to take up the open space that's available on the other side. And that, my friends, is wind.